Good afternoon. So we begin today chapter 4 with lesson 4.1 dealing with systems of linear inequalities. This introductory lesson is not that difficult, but if you didn't do this type of work before, it might sound or look very unfamiliar. And this is another lesson in which you really have to take your time to go through understanding the main idea of what we mean to solve a linear inequality. And then, of course, we will move on to more applications, primarily from economy. But to begin with, let's actually talk about what we mean by linear inequality and what we mean to solve it. I will give you plenty of motivations for why we need to do that. Just a verbal one before I write down a real life application. Obviously, and I think I mentioned this previously very briefly, obviously many conditions in business planning are not equalities, but inequalities. And if you can pay attention to keywords like, for example, I have up to $1,000 to invest, or I need to make at least 100 products of a certain type. These words, at least or at most, suggest inequalities, not equalities. So for example, if I say I need to invest up to or at most $1,000 in two different stocks, let's say, or two different deposits in a bank, you can imagine essentially the unknown being the amount in each deposit. And then when you sum up the two, you don't actually have equality with $1,000. You have less than or equal to 1,000. So you have a constraint in the sense that more you can't do, but less for sure, right? Because you don't have, let's say, more than $1,000. So you can certainly invest less, but not more. And that gives you a condition in the planning of whatever you want to do in terms of inequalities. And we call them linear inequalities because, like equations before, we focus only to linear equations. I mean, linear terms depending on those variables that you use in the problem. So let's actually start with a quick example to illustrate what we mean actually to solve an inequality, a linear inequality. And we'll start with a very simple one. Suppose I want to solve, and again, the key word is to understand what we mean by this word. We want to solve the inequality x plus y greater than or equal to 1. And let's say x and y are some physical quantities, like for example, number of items of a certain type, which means they can't really be negative numbers. So let's say x greater than 0, y greater than 0. But let's focus on the first inequality, and then we'll worry about the positivity condition if you want. Well, remember, if you forget for a moment that you have an inequality sign here, and you actually change this with the equal sign, so if you look at the actual equation or equality, x plus y equals 1, this one, if you sketch it, is a line. Right, so it represents a line in the plane. And so remember, to sketch any line, you pick 2 points on the line. Most of the time you give 0 to one of the coordinates and solve for the other. So 0, 1 is one of the points. Or you can alternatively give y equals 0, and then if you plug it in, then x equals 1. So basically 1, 0 is another point. So once you have 2 points, you can sketch the line. You don't have to plug in 0. Let's say I can plug in 2, and that means y equals minus 1 if you solve for y. So another point is 2 and minus 1. The reason why we often plug in 0 is because it's easy to compute these coordinates. So whenever possible, we plug in 0 to pick up the 2 points. But you need only 2 points to sketch the line. So let's sketch it over here. In the coordinate system, so we have the point 1, 0. Remember to label the points. You don't need to be really that picky on counting the number of units. Just make sure the labels make sense in relation to each other. So that's the point 1, 0, and that's the point 0, 1. Sometimes you may prefer actually to write both coordinates near the point, depending on the case. and this is the line that is x plus y equals 1. So I want you to pay attention at this moment and realize that each point or pick on the line, right, I'm emphasizing these points here, each of them will satisfy the equality x plus y equals 1. Now, on the other hand, if you are at any point above the line, pick any point above the line. Let's say you're here, I'm marking these points here, here, here. It's not that hard to realize that each of them, if you actually draw a vertical line, basically it's like moving a point on the line and adding some positive quantity, in this case to the y coordinate. Or you could maybe draw a line, a horizontal line from a point here, and then it's like picking a point on the line, and to move right, okay, to move to the right of the line, you basically add to the coordinate, right? I mean, you add to x if you move horizontally. So what I'm trying to say here is that each point you pick in this region, which I'm going to basically hash it like I'm painting it essentially. We won't have to do this too often, but just to illustrate. Each of these points in these regions on one side of the line will satisfy the actual inequality. So they will satisfy any point on this region, it will satisfy the inequality x plus y greater than or equal to 1. So intuitively, you will realize that if you are on one side of the line, each of those points will satisfy the inequality in one sense, in one direction or another. And it's very easy to pick which direction it is. You can simply pick a test point if you're not sure, because sometimes it's not easy to guess. In this case, the line is kind of symmetric to the points 0, 1, and 1, 0. So you could kind of guess, like I told you here, that all the points on that region satisfy x plus y greater than or equal to 1. And by the same argument, if you pick any point to the left of the line, and I'm gonna mark or illustrate that region with a different type of painting if you want, I mean with slightly different angles for these lines, each point you pick here on this region, this will satisfy the inequality in reverse, x plus y less than or equal to 1. If you have strict inequality, it's the same region but except the line. So for example, let's say I want to solve x plus y strictly greater than 1. Well, it's the same region, right above the line or to the right of the line, except the line itself. Because on the line, remember, it is exactly equal to 1. So this quick example illustrates the main idea on what we mean by solving an inequality. So the first remark we want to make, and let's actually add a remark here. The solution of an inequality is not just a pair of numbers, is a region in the plane. Meaning that you have already, you have infinitely many possibilities. I mean, that's not hard to realize that if someone says, how many combinations can you find such that x plus y is greater than or equal to 1? I mean, obviously there are infinitely many possibilities, 3, 5, 1,000, a billion, I mean, infinitely many possibilities, but it's not like you can plug in any number. Obviously, if you plug in, let's say, -3 for x and -5 for y, that won't be true. So it's not like you have the whole plane as a solution, but the region of the plane. And as it turns out, in the case of linear inequalities, you always have one side of the line. So basically, each line separates the plane into two regions, one satisfying the linear inequality in one direction, and the other region satisfies the linear inequality in the other direction. So as a quick recipe of how we solve linear inequalities, so let's write it here. So how to solve linear inequalities. And we can actually describe them in a general form ax plus by greater than or equal to c, or in reverse, ax plus by less than or equal to c. Same idea. So a, b, and c, of course, are the coefficients. It doesn't really matter how you actually write the inequality. This is just like the standard format coming from the equation on the line. So in the first step, you're going to sketch the line ax plus by equals c. So you basically replace temporarily the inequality sign with equality. So you sketch the corresponding line ax plus by equals c. Step number 2, pick a test point. Let's call it x naught, y naught on one of the sides of this line. Okay, so pick a test point on one of the sides of this line, right? The line separates the plane in two regions, and plug it in into the inequality. Plug it into the inequality that you have to solve, right? Either ax plus by greater than c, or the other one less than c. If the inequality is verified, then that region is the solution of the inequality. If not, it's the other one. It's as simple as that. It's one of the two sides. And the easiest thing to figure out which one is which is just to pick a test point for one of those regions. So let's do a quick example in this part here. Suppose, for example, I have to solve, another example than the one before. So suppose I have to solve minus x plus 2y less than or equal to 6. All right, so the first step, step number 1, is to sketch the line minus x plus 2y equals 6. And take some time to pick up 2 points. You should probably pause the video just for practice and pick 2 points and sketch the line. If I plug in 0 for x, 2y equals 6, y equals 3. So one of the points is 0 and 3 in that order. And if I plug in y equals 0, then x is equal to minus 6. So again, the points, let me write it on the left side here. So the points I picked, 0, 3. Remember, always the x coordinate is the first one. And then the other point is minus 6 and 0. And let's sketch quickly the line. X equals 0, y equals 3. So suppose this is where 3 is located. And then if x is minus 6, I'm going to have to make it like twice as much on the left side. Suppose this is minus 6 and y is 0, so that's the other point. And this is the line in question. Kind of messy here, but I made it like I want to make it thicker, but I hope you get the point. So that's the line. All right, so which region corresponds to the inequality that I try to solve? So here's a little trick of the trade. If the origin, if 0, 0, that I emphasize right now here, is in one of the two regions, that's the easiest test point. So the easiest test point is 0, 0. If I plug in 0, 0 into the inequality, so that's basically step 2, minus 0 plus 2 times 0, does that satisfy the inequality? Of course, you could do that in your mind. I just make sure that I illustrate so that people understand what we're doing here. So you plug in the test point you pick. The test point will verify one region below or above the line. So basically by picking the test point, I'm essentially checking the region below the line. I plug in 0, 0. It looks like it satisfies the inequality. So the entire region below the line will be the solution of the inequality. And when you write down the homework, that's as far as you go. Basically, you show by this painting, essentially, by these hashed lines, that you have, that's the solution of the inequality. Obviously, let's suppose that in another example, you had, in fact, to solve minus x plus 2y greater than or equal to 6. So if you were to plug in the same test point, you ask yourself, is that true? No. So obviously, for this inequality, for minus x plus 2y greater than 6, it's not that region, it's the other one. So I'm going to mark this down now with a different type of line, right? So this region now will satisfy, of course, the inequality in the other direction. Because obviously when you sketch these regions, you kind of make a mess. Like I said, after you get used to visualizing these regions, you probably don't have to do this type of lines too much, so that you don't make a mess. Once you visualize it, often you will be able actually just to emphasize the borders of the region, because you will see when you come up with more than one inequality, when you put things together, the solution often is actually a closed region of the plane. One thing I want to mention before we move on to the second page, let's say, for example, if I go back to the first example, so look back to the starting point here, when I said, let's figure out the region when x plus y is greater than 1 and x positive, y positive. So you do these inequalities one by one, and you actually intersect these regions. I'll show you with more examples later on the second page. But once you establish that x plus y greater than 1 is all the region above the line, then you can restrict that region just to positive x and y, if that's the question in the problem. So this is where you could emphasize the borders of the solution, right? So you don't take the whole region above the line, but only the one restricted to positive x and positive y. So notice you have essentially some corners that come up because of intersecting these regions. And these corners will be important later, as you will see. So stay tuned for more examples on this topic. Okay, so I want to start this part by asking you please to pause the video, write down this problem, this application, because I really want to discuss a little bit before we move on to how to solve it. So really, I really ask you to pause and write first, because it's important for you to listen to me as I walk you through some of the elements of this problem. All right, so suppose, assuming that you just did that, let's read it together and pay attention to the keywords that lead to constraints, to conditions in the problem that are expressed in terms of inequalities. So we talk about a brewery in this story that makes two types of beer, type A and B. The ingredients for type A cost $5 per gallon, and the ingredients for type B cost $10 per gallon. And say the capacity of production is 100 gallons per day. So that's how much this brewery can make in terms of the quantity per day, 100 gallons. And this brewery also has $800 available each day for purchasing the ingredients. So there are some limitations in terms of the money per day, and then some information about the cost. How many gallons per day can be made for each type? So I want you to notice that for sure the inequalities will be less than or equal to, because these constraints clearly are upper bounds, so to speak, on these on these conditions, on the requirements that to make the beer in terms of the money to purchase the ingredients and how much beer you can make per day. So for example, whatever the cost of production is in a given day, it cannot be more than $800. So when they go to purchase the ingredients for a given day, whatever the combination can be made, the cost cannot exceed $800 because that's how much they have available. No matter what combination of beers of each type they can do, altogether that cannot go above 100 gallons per day. So this should be clear from the beginning that the problem will lead to inequalities. How many gallons per day can be made for each type? So that's the question in the problem. Never rush when you go through these problems to guess through and write the equations. It's extremely important to write down not only the variables, but in words, the meaning of each variable. Because if that's not very clear from the beginning, then you're going to be prone to set up these equations in the wrong way. So let's denote by X the number of gallons of type A per day. So the number of gallons of beer of type A that can be made in a given day. And by Y, the number of gallons of type B per day. All right, so once that's clear, then let's see how we can write the conditions in the problem. Well, to make 1 gallon of type A, you need $5 in ingredients. To make X gallons of that type, you obviously need 5 times X. So 5 times X is the cost of making X gallons of, or the cost of the ingredients for making X gallons of type A. To which you have to add the cost of making Y gallons of type B, which remember, it'll cost $10 per gallon. So that's going to be 10 times Y. And altogether, this should be less than or equal to 800 because that's how much money you have in a given day for the ingredients. Altogether, you cannot produce more than 100 gallons, which means X plus Y, which represent the number of gallons, cannot exceed. So that means it should be less than 100. And of course, another restriction is that you can't have a negative quantity of gallons. That'll be really fun and sad at the same time. Both X and Y should be positive. This is not given in the problem, but this is basically a natural constraint. I mean, it's implicit already because we can't have a negative number of gallons. And the other ones are just regular constraints in the problem. So we have what we call a system of inequalities. And remember, when we solve the system of inequalities, we have to solve each inequality at a time and take the common part of the region. You already know that each linear inequality gives you one side of that line as a solution. But that needs to be now superimposed with the solution for the other linear inequality. So this way you could solve systems of 2 or more inequalities by simply superimposing the regions for each of them. Obviously, we're going to do later a much more efficient method without relying on graphing. But for now, we solve these problems with the help of graphing these lines. Okay, so let's start by sketching the region for each of these lines. So we're going to take line 1, which is the line corresponding to the first inequality. Because remember, the first step is to sketch these lines. And line 2 will be X plus Y equals 100. Often you could simplify if you can. So notice here we can take advantage that each of these coefficients is a multiple of 5. So I can divide by 5 all of the coefficients. 800 over 5 is 160. So when I sketch the line, I can use, smaller numbers. Let's plug in 0 for X. That gives me Y equals, so 2Y equals 160, which means Y equals 80. So 1.80 on this line, and let's actually separate them like that. So one point on the line is 0, 80. And then let's pick another point. If y equals 0, obviously x equals 160. So one other point on the line is 160 and 0. And let's pick the points on the second line. This is a kind of easier, right? So if x is 0, y equals 100. If y is 0, obviously x equals 100. So 100, 0, 0, 100 are the two easy points to pick on the second line. So I'm going to do the graph over here on the right side of the page. And at this point, notice it's extremely important to label these points correctly with respect to each other. So nobody will ask you to count 80 units or 160 units on the coordinate system. But for example, if let's start with line number 2, right? So if this is 100, 0, and this is 0, 100, the other point, make sure that the other points that come from the other line are in a correct position with respect to 100. So for example, if it's less, make it to the left of 100. This is extremely important so that you can get an accurate picture of how the region looks like when you sketch these lines. So let's draw the line number 2. This is actually line number 2, the way I actually labeled it. So this is L2, the x plus y equals 100. And let's sketch the other line. So the other lines, one point is 0, 80. So 80 should be below 100. Again, pause for a moment. This is extremely important because if you misplace it, this point, above 100 by mistake, the picture will not be correct. And it will not give you an accurate or a meaningful representation of the region. So that's 0, 80. And the other point is 160, 0. So 160 should be further to the right of 100. And you can exaggerate how much to the right it is just to get a nicer picture. What's important is to make it to the right of 100, because obviously 160 is greater than 100. And this is going to be now the second line. I label it line 1, right? So that's the first line. X plus 2y equals 160, or before simplification, 5x plus 10y equals 800. All right, so let's see now the region given by each of these inequalities. Going back to the first line, let's pick a test point. Now notice in both cases, 0, 0 is a test point that I can use because it's not on the line itself. So by picking the test point 0, 0, I am essentially checking the region below the line. So I'm checking the region below the line. And let's plug in, excuse me, let's plug in 0, 0 in the first inequality. 5 times 0 plus 10 times 0. Is it less than 800? Well, it's 0 plus 0, 0 less than 800. True. So therefore the inequality solution is the region below line 1. So I'm going to do this region, I'm going to represent it by these lines like that, kind of horizontal lines. The same test point for the second line. I mean, you could actually figure out in your mind, right? 0 plus 0 less than 100, because remember, you plug in the test point in the inequality itself, right? In the inequality x plus y less than 100. And of course, the inequality is true. So therefore, the region below the second line is part of the solution. And it's important at this point to sketch that region with a different pattern. So for example, I'm going to sketch it with lines with a different angle, right? So just make sure it's a different pattern. And what matters here, and let's write here to the close to the picture itself, the solution of the system is basically, remember, the common part of these regions. That's what you're looking for. The region that is satisfied by both inequalities. Now remember, we also have a positivity condition. Don't actually sketch anything extra because you're really going to make a big mess if you do that. Just notice that if you restrict yourself to x positive, y positive, you really only care about what happens over here in the first quadrant. You basically ignore all the other region when x is negative and y is negative. So in the positive region, because x and y is positive, which is the region that is painted or marked by both part patterns? Well, it's going to be right this quadrilateral, right? This portion enclosed by the two regions that I basically emphasize right now by making these lines a little bit thicker. That is the solution of the system of inequalities. And another important question you may see later is to find the so-called corners, if any, in this region. But before I move on to that, again, I hope it's clear for everybody, because later on you should be able to do this without actually drawing this pattern, so you don't make a mess. You visualize the two regions and how they intersect, and then you simply emphasize the borders of the region. So what do I mean by solution of the system? It means that to satisfy the conditions in the problem, you have to pick a point in the interior of this region, this closed region. Any point on that interior will satisfy the inequality. You still have infinitely many solutions, but those solutions are restricted to that interior of that region. The corners will be very important for a reason I won't get into right now in this lesson. And so that's why some of these problems in the homework will ask you to figure out the coordinates of the corners. Now, some of the corners are already given. 0, 0, 100, 0, 0, 80. Those are the corners that you already found when you sketch those lines. But there is another corner that is not found yet over here where the two lines intersect. And for that, you just have to solve the system given by the equations of the line. So make sure you don't confuse the inequalities with the system that finds the corner point, right? So you take the two lines that border the region, L1 and L2, and you form a system and you solve it by elimination and find the coordinates of that corner. So for example, I can subtract the second equation, let's call it row 2 minus row 1. Since we have only two variables, we don't have to complicate ourselves with the matrix, with the augmented matrix. Just subtract the two equations and you get 2y minus y equals 160 minus 100. That makes y equals 60. And if you plug it in the first equation, for example, you will get x equals 40. So this corner is 40 and 60. And this is a typical word problem in this section. Set up the coordinates, the condition, the constraints, solve the system of inequalities that results from it, and find the corners. So I'm going to do another example before we call it a day, in which the test point cannot be 0, 0 because it happens to be on the line. And then that will be it for this lesson. Make sure you go slow on it and don't move on until you master every single example. All right, so just like I asked you before on the previous page, please, it's very important, pause for a minute and write down this example. This is actually from the book. If you prefer, you can take a look on the book, but it's better to just take a moment and write down the problem on your notebook. And after you do that, then just listen to me before we move on with the equation. Or you could also try to actually do it and then check with me to see if you did it correctly. It's up to you, but either way, make sure it takes some time to to write this down. Remember, I always assume you use the pause button. And you should do that because that's the reason why I don't take too many pauses when I move on to the solution, because I'm expecting you to make use of the pause button. All right, so assuming you did that, Kathleen, let's read the story. Kathleen wants to invest up to $40,000 in bonds and stocks. She wants the amount in bonds to be at most 1/3 of the amount in stocks. And the question is to write a system of inequalities describing possible amounts for each investment. Once again, be very careful and make sure you recognize the words that describe the inequalities and the direction of the inequalities. So, obviously we're going to have two unknowns, right? Because possible amounts for each investment, that means two types, right? Bonds and the stocks. We want to invest up, or she wants to invest up to 40,000. So less than that, right? She cannot invest more than what she has. So the condition will be a less than or equal sign condition. Up to 40,000, at most 40,000, not more than 40,000. Various words can describe the same direction of the inequality. You just have to be careful to make sure you put it in the right direction. And it also has to make some sense, right? I mean, if she has $40,000, she cannot invest more than that, right? I mean, it makes sense that the inequality will be with less than or equal to. Then the other inequality, the other condition can be either way. So again, you have to be extra careful to make it in the right direction. She wants the amount in bonds to be at most 1/3 of the amount in stock. Again, it's a condition of less than. So the money in the bonds should be less than 1/3 of the amount in stocks. As before, let's denote the variables. Let's say X is the amount of money, the dollars in bonds. And then Y is the amount of money in stocks. Very important to write down the meaning of the variable, because you need to translate the conditions given this meaning, right? So what is the system then to solve? Well, she doesn't have more than $40,000. So that means the sum of the investments, X plus Y, should be less than or equal to $40,000. And now she says that she wants the amount in bonds, which is X, to be at most, so not more than that, maybe less, but at most 1/3 the amount in stocks. So less than 1/3 times Y. Once you establish the inequality, you can do some algebra to simplify your equations. Actually, let me do it because I don't have room on that corner. You can actually multiply by 3 just to eliminate the fraction. So you can manipulate the system just to make it easier to maneuver. And moreover, actually, you can write it in the standard way with X and Y on the left side if you prefer. Not mandatory, but if you want to match it with the general form, ax plus by less than or equal to c, you can certainly do that. So basically write each of these. So actually it's a good practice to do that actually for later. Right now it doesn't matter, but later actually the way you write it down might make a difference when we apply other algorithms. So these are the two conditions. X plus y less than 40,000, 3x minus y less than 0. Remember, when we sketch the system of inequalities, we start by sketching the corresponding lines. So you pick each inequality, you replace that inequality sign with equal sign, just for the purpose of essentially sketching the boundary of those regions, right? The line itself. Just like before, the points to pick, the easiest ones are obtained by plugging in zeros for various coordinates. So if y is 0, x is 40,000. So 40,000, which means the points themselves are 0, 40,000, 40,000, 0. For this line, You can also plug in 0 for x, but notice if x is 0, then y is 0 as well. So 0, 0 is on the line, which is the reason why you will see you can't actually use it as a test point. And let's pick another point. Let's say x equals, now you have to choose another value, because if you choose y 0, again, x is 0, so it's the same point, 0, 0. So let's say x equals 1, just choose lower numbers, and that means y equals 3. So another point possible on the line is 1 and 3. And let's do the sketch over here. Oh, I forgot another condition to begin with. Obviously, x positive, y positive, right? I mean, you can't invest a negative amount of money. So let's start with 40,000. So obviously you have to basically say that this is the point. Just pick a point at a reasonable distance from 0. Just make sure these points are equal to each other because they are symmetric, right? So this is 40,000, 0. Over here, this is 0, 40,000. And that is line 1. And the other one, here you have to exaggerate a little bit, because if I write this at scale, you won't be able to see the point 1, 3. But nobody will ask you to do that. You can exaggerate as long as 1 is less than 40,000. That's all that matters. Now don't forget, one point on this line is 0, 0. And another point that I picked was 1 and 3. So suppose this is 1 and 3 over here. And that means the second line will go like this. So that's line 2. Okay, so what are the two regions that will have to intersect? Well, just like before, for line 1, we can pick 0, 0 as a test point. Right, plug in 0, 0 into the inequality. That's going to be 0 plus 0, which indeed is less than 40,000, so that's true. So that means the region where 0, 0 belongs to, that is to say below or to the left of line number 1, is going to be the region that describes the solution of that inequality. And now you can actually skip the negative region. You already know you won't care about any of that part here when, when x, where y is negative, right? So anything below the x-axis or to the left of the y-axis. Okay, let's pay attention to the line number 2. So now we have to test either the left or the right side of the line. We cannot pick 0, 0 as a test point because that's exactly on the line. So for example, I'm going to pick a point to the right of the line. So let's pick a point, for example, in fact, you can even pick 40,000, right? I mean, it doesn't have to be near the line. Any point on the line to the right of the line number 2 will test that region. Okay, so I can basically use as a test point 40,000 and 0. Just make sure that the point you pick really is indeed to the right of that line, if that's what you want to test. So if I plug in 40,000 and 0 into the inequality, right, we're testing the inequality, so that's 3 times 40,000 minus 0, is it less than 0? So obviously this is false. So the inequality is solved not by region to the right of the line, but to the left of the line. So the left of the line is the region in question. So I'm going to sketch that left of the line region with a different type of pattern. All right. And remember, you only care about the positive and the negative region. So now if I restrict myself to the positive region, the region that has both patterns, remember that's what you're looking for, the region for both patterns when the two regions intersect, happens to be this triangle that I'm emphasizing right now. So that is the region that solves the inequality, the system of inequalities. And just like before, it will be important for later to find the corners. Two of them are already given. So one of them is 0, 0. The other one over here is going to be 0, 40,000. And the other one, I need to find it where the two lines intersect. So you have to solve the system x plus y equals 40,000, 3x minus y equals 0. We can do a quick elimination by adding the two equations. So that gives me 4x equals 40,000, or x equals 10,000 if I divide by 4. So if x is 10,000, then y from the second equation, y equals 3x. That's 3 times 10,000, which is 30,000. So the corner in question has coordinates 10,000, 40,000. Again, you will see later that this corner, and I mean one of these corners, will have an important meaning in terms of optimizing some of these economics inspired problems, so to speak. So that's it for today. Please take the time and don't go slow on this homework, because it's very important to master what we're talking about here in order to have an easier time with later sections. And that's it for today.